Now let's look at some special lines. We're going to start with horizontal and vertical lines, and then we'll look over at parallel and perpendicular. Horizontal lines are all parallel to the x-axis. Those are these lines here on our grid going east to west. These are all parallel to the x-axis, and they all have the same general form of equation, which is y equals k, or k is a constant. K is some number. And we can find a lot of information about these horizontal lines in general. So let's think about this graph we have here. In this graph, we can pull out some points. I'm going to pull out some random points here. Let's pull out 3 of them. Got 3 points. These points are -4, -3, -2, -3, 2, -3. Now, as I wrote those points out, you may have noticed something. For all 3 points, the y value is -3. This intersects the y-axis at -3. Our y-intercept is 0, -3. This is because with a horizontal line, this one in particular, because we're looking specifically at this one, it doesn't seem to matter what our x value is. Our y is always going to be -3. And that's what that k represents when we talk about y equals k. This k represents the number in which our y value will always be. And that k value happens to be whatever our y-intercept is. So when we find our y-intercept, in this case it's -3, that gives us what our k is. So essentially, in terms of the language we already are used to, our k is our b when we're looking at y equals mx plus b. We are looking at y equals k in terms of our standard form, but if we think of y equals mx plus b, we could also say that it can also be written in this term here, or in this way as well, where k, or where the equation is y equals b, where k and b are the same number. They're both -3. So we actually know that the equation of this line is going to be -3, because no matter what my x value is, my y will always be -3. And that just happens to be the equation of the line, y equals -3. Now, you may notice that my slope, when I went to the y equals mx plus b, I put my slope as 0. Now, how did I know my slope is 0? Well, I wanted my equation to look like this. And in order to say b and k are the same, I needed x to go away. And x went away here. And I know there's no x here. So I had to make x go away here, which is why I put the 0. But can we prove that x is 0? Or that our slope is 0? Well, we know slope is the change in y over the change in x. And if we look at our points, say the first 2 points, which are these 2 points here, on the left and the middle, if we are looking at their change, the change in point 1, -4, -3, to our second point, which is -2, -3, the change in y, it looks like it's going, or sorry, we'll start with the change in y. From -3, -3, it doesn't change. It changes 0. From -4 to -2, that's our change in x, it changes by 2. Well, 0 divided by 2 is 0. So our slope is 0. And that is actually true for all horizontal lines. Your slope will always be 0, and your y-intercept will always be whatever your k value is. So if you have your equation, you know your y-intercept and you know your slope. And any horizontal line or any equation that can be written in the y equals mx plus b with our slope being 0 is going to be a horizontal line. What about vertical lines? Well, vertical lines have a similar standard form equation. Notice that instead of being y equals k, we have x equals, and it changes to h. And h and k are going to be important variables if you continue on to like Math 111 and 112, which is why it uses h and k. Those variables are used later in further math classes. But we have a x, and over here we had y, and then now we have h. And the standard form is similar, except instead of a 0 for x, we have a 0 for y. Well, let's pull out some points like we did before and kind of analyze a few of these. So these are some points like before. We have -1, 4, -1, 2, and -1, -3. Looking at this, I'm noticing that my x value is always -1, which explains why it says that x is going to equal some number, h, which is a constant, some number. So in this case, my h is going to help me write my equation. So x is always a constant number. In this case, it's my h, which is -1. My equation of this line is x equals -1. And that happens to be my x-intercept, which is -1, 0. And so my x-intercept is going to be my h value, -1, 0. Now what about slope? That's my change in y over my change in x. Well, let's see. First 2 points are the ones we'll kind of look at. The top one and the middle one. So -1, 4 and -1, 2. Change in y going from 4 to 2 is going down 2. And that's a change of -2. And then my change in x is -1 to -1. So there's no change. That's 0. But when I do -2 over 0, I can't divide by 0, which means my slope is going to be one of those that are undefined. When we talked about 4 different types of slopes, we said that if we're dividing by 0, we have an undefined slope. And so anytime we have a vertical line, our slope is undefined. So now we know what our slope is, and we know what our x-intercept is. One thing to know is for a vertical line, we can write a vertical line in standard form. However, it is impossible to write it in slope-intercept form. A vertical line cannot be written in slope-intercept form at all. And that is because we don't have a slope. So we can't have y equals anything because there's no y. There's no slope. The next thing we're going to look at, parallel and vertical lines. So parallel lines run side by side. They go beside each other on forever, never to intersect, never to meet, destined to be close, but never to meet. The thing about parallel lines is that they will have the same slope. And that's the reason why they never meet. They're going to constantly change at the same rate. And because they're constantly changing at the same rate, their trajectory is going to stay consistent and they will never intersect. And so a quick way to determine if two lines are parallel is to look at their rate of change and determine if it is the same. And if it is, then you have yourself parallel lines. And if it's not the same, then you do not have parallel lines. You might have perpendicular, or you just might have neither. So what I'm doing here is I'm creating my slope triangles so that I can quickly determine my change in y over my change in x for both my blue line and my red line. So starting with blue, looks like we're going to go up 3 and then to the right 1, 2, 3, 4, 5, making my slope 3 over 5. And for my red line, we're going to go up 1, 2, 3 and right 1, 2, 3, 4, 5, making my slope 3 over 5. They are the same slope. Both of them are 3 over 5, which means these lines are indeed parallel lines. What about perpendicular lines? Well, perpendicular lines are, they're going to intersect at a 90-degree angle. Vertical and horizontal lines are always going to be perpendicular. And I didn't mention here that any two vertical lines are going to be perpendicular. And the same slope thing is for anything that's non-vertical. The reason it says two vertical lines is we just said that vertical lines have no slope. And so we can't use the same slope rule for vertical lines. We just have to know that vertical lines are going to be parallel and everything else should have the same slope. For perpendicular lines, we have that vertical and horizontal lines are perpendicular. And we have to know that because, once again, vertical lines have no slope. So we can't compare their slope to anything because they have no slope. But we can know that a vertical and a horizontal line will always be perpendicular. But for any other set of lines, we need to analyze their slopes. So the thing we need to know about their slope, if they're not vertical and perpendicular, or if they're not vertical and horizontal, then we can look at their slope and they will be perpendicular if and only if their slope, the slope of 1, is the negative reciprocal of the slope of the other. Now, what the heck does that mean? Well, what that means is that the slope of one line, say our blue line in this case, I'll put B for blue. When I multiply the slope of our blue line times the slope of our red line, in this case is R, we should get -1. So it says the slope of one line times the slope of the second line equals -1. You might actually, I'll write this how you might see it in the textbook, in other places, is one slope times the opposite reciprocal of another slope is -1. So opposite reciprocal, opposite means one's positive, one's negative. Reciprocal means that one is kind of like flipped if you put it at the bottom of a fraction. And that still works if it is a fraction. So if I have 1/4 and then I put it over 1/4 like that, that actually kind of flips to become 4. But we are quickest way, so you don't have to worry about flipping fractions and stuff. You can just multiply them and see, does it give me -1? So this blue line is the same line from before. So my blue line, we know our slope is 3/5 because that's the same line. The red line is not the same. So we do have to find our slope for the red line. So let's create our slope triangle. And it looks like 1, 2, 3, 4, 5. We're going to go up 5. So change in y is 5. And the change in x, it's going to the left, so that's negative, and it's going 3, so -3. So it looks like my slope is -3/5. So I'm going to multiply the slope of my blue line times the slope of my red line. And I did not write that properly. Let's try that again. The slope of my blue line, that wasn't what was written wrong. It was this one that is written wrong. My goodness. Good thing I caught that before I ended the video, published it, and sent it out to you, huh? All right, there we go. So, slope of our blue line times the slope of our red line. And to solve this, I multiply across the top, multiply across the bottom. You can simplify before you multiply if you'd like. 3 times 5 is 15. And 15 divided by 15 is 1. So this will give us 1, which means these are indeed perpendicular.